Hello everyone, Gary here from RC Street Wars and Exotek Racing. Today we are going to start a multi-part series on your speed controllers, how to tune them, how to set them up, and we're going to go through three different styles of speed controllers. We're going to start out today with what's arguably the most popular, and this is going to be the Yokomo slash R1 style speed controller. I'm going to tell you for our preference, we prefer the Yokomo speed controller over the R1. Even though functionality-wise, tuning-wise, they're identical, there are a few things that I think make the Yokomo better, and I recommend it over the R1 version. And we'll get into that as I take it out of the box. But for today, we're going to do a brand new setup. I'm going to go over the tuning. I'm going to give you some base tips, and we're going to go from there. So for those of you who do not know, the Yokomo and the R1 speed controller are made by a company called Gropner, and they're out of Korea and Germany. So Gropner Racing actually makes the Yokomo, they make the R1. The Gropner app, the Yokomo app, the R1 app are all identical, in most cases interchangeable. So if you have a R1 Wi-Fi module, this is a Yokomo. If you have an R1, it'll work on here. The Yokomo won't work on here. The Yokomo Wi-Fi module will work on R1. They all totally interchangeable. All right, that being said, I'm going to start with a brand new. Everything is sealed up, brand new. Everything is going to be right out of the box. So let's get going. I'm going to cut open the box and take the Yokomo Speedo out. So here is the Yokomo Speedo, and I'm going to go over the things that I like about it first. First thing you're going to notice is the terminals are not pre-soldered. I like this better because instead of taking a speed controller that already has solder on it and to be sold in the United States, they have to use that no lead solder, which is just terrible for us. We can start with a very clean, fresh surface. We don't have to worry about putting lots of heat to the Speedo to get the old wires off. We can put the wires we want on it the first time, and we can use the solder that we prefer the first time. So for me, this is something that's absolutely huge. Okay, so like I was saying, for me, this is a critical thing because I like to put my own wires on, and I want to know that I did it right the first time and I did not overheat the speed controller. The second thing I like about this speed controller better than the R1 is there are cooling ports on the speed controller, and these are designed in such a way that it actually allows airflow to move across the board, across the drivers, the MOSFETs, and help keep it cool. We know how important keeping the speed controller cool is. The third thing that I like about this one, it is technically rated at 20 more amps per phase than the R1, and I have no reason to doubt that claim. Gropner, the company that makes it, is a very reputable company. I have checked the specifications out thoroughly, and yes, it is indeed, I sent them a note, it is indeed rated at 20 more amps per phase than the R1 version. I guess that's just what Yokomo went with. The last thing about this speed controller that makes it better, in my opinion, is the fact that it comes with a removable switch. Now, we all know that the R1 version of this Speedo has got a terrible switch, and it's pretty much a mandatory upgrade. What's amazing about this is, one, I believe the switch to be a higher quality, but two, what I like better about this one, they must have done something different with the on-off circuit, because this speed controller, the switch is naturally closed. It's a closed contact. What does that mean? It means that if you do not have the switch installed, as soon as you plug in the battery, the speed controller will power up. So if you do not run the switch, you plug in your battery, the speed controller powers up. There is no way for this thing to turn off because of a switch failure. All right, short of you ejecting your battery from the car, this will not turn off. You'll not turn off at the line. You won't even forget to turn on your car, which I already know so many people that have failed their race before it even started because they set it down and just forgot to turn it on. Your battery's connected, this thing's on. I highly recommend you doing that. It is a completely foolproof way of running your car. All right, guys, I'm back. So what I've done is I have connected 2 leads to the speed controller, just using alligator clips, positive terminal, negative terminal to a battery, and I've plugged in my Wi-Fi module. Now, because I am actually using the Yokomo Wi-Fi module, you will see under your Wi-Fi settings, it will come up as BL-WMESC. This is the BL Wizard. This is the name of the Yokomo version of the app. If this was an R1 Wi-Fi, which would be fine, it would just say R1 works here. But anyway, for those who don't know, the standard password for all these, whether it's a Gropner, an R1, or a Yokomo, is a 1, 2, 3, 4, 5, 6, 7, 8, 9, and a 0, and then just join. So I've already joined, and we will now look to open the app. So you see here, I have BLWM Wizard Yokomo, okay? When you open the app, it's gonna look like this. You know you're connected. Up here, it'll tell you that you're connected. And you see settings, live, log, update, and these are, so let's go over your Wi-Fi. This is kind of the first thing I like to do because I just want to get it out of, the normal range and the Wi-Fi. Just get it out of the way. So for me personally, I do things in C, but if you like Fahrenheit, that's fine. I put my RPM range all the way and make sure that is all the way here. All right, my volt range I will keep at 10. My current is maxed out at 300, and this is your battery capacity, 75 or 10,000. You can just leave it here. So make sure these look about right. This is going to help set the scaling when you look at your data. So if you aren't defaulted to these, just 10,000, 10 volts, 300, 100,000, sorry, 10 volts, 300, 10,000 mAh is good. You can just change your scale. So Wi-Fi always on, module version, blah, 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 channel 1. All right, that's good. Now, I will tell you, if you want to change your SSID and the password, this is where you do it. But once you change it, it's going to disconnect you, and you're going to have to reconnect with your new password. So for right now, for the sake of the purpose of this video, I'm not going to change it, but I do recommend people changing it to something unique and a unique password, because people will look to connect to your stuff at the track, and maybe inadvertently, maybe accidentally, but maybe they could screw it up or change it, or you're not aware. So just make this a unique password. It's going to save you a lot of trouble. So this is kind of the first thing I do. But for right now, let's get back to the rest of the settings. So we're going to go in the setting menu. And what I'm going to do today is go through what everything is. And then we're going to walk through a very basic setup for both prep and dry tire. All right. So if you see here, we have LiPo, Li-Fi, nickel metal hydride. We run a LiPo battery, so that's going to be selected. Cutoff voltage, instead of auto, now this is only for drag racing, guys. If you are not drag racing, leave this on auto. But if you are drag racing, set this to disabled. This is going to help you when your battery may get a little bit low during a run. It doesn't interfere with turning off the speed controller. So if you are not drag racing, set this to auto. Otherwise, if you're doing some road racing or something like that, maybe 3.3 or 3.0 is good. That's you really should never be below 6 volts, but especially for anything that's not drag racing. But for drag racing, guys, disabled. All right. Now, motor direction, normal or reverse. All right. The normal direction for any motor in RC, I don't care what it is going to be counterclockwise. We consider counterclockwise the normal direction. Now, there are some kits and some installations out there that require the motor to go clockwise. In that case, you will reverse the motor here. Why we do this is because this speed controller is a sensored speed controller. It has a sensor wire. The sensor wire is going to be detecting the direction of the motor, and it's not like in the old days when we had sensorless speedos and you swapped two wires to change the direction of the motor. Here we have to do it in the speed controller. So guys, if you're new to this kind of speed controller and you're used to swapping the wires and you need to change your motor direction, you have to do it here. All right, I really need to stress that 110%. You must do it here. Do not try to change the wires. Gear ratio. This is really just for some things that happen in data logging, but as good measure, I like to set it to something that I'm going to run. So let's just say 8.6 because that's a pretty good number. Now, for drag racing, guys, your tire diameter is about 105 to 104 millimeters with the crush. So I use 104. But if you're on-road racing or something like this, just get some calipers and measure your tire and set it here. It's just good measure. Really, like I said, this is just for your data logging. Your BEC voltage, what this stands for is Battery Elimination Circuit, BEC. This is old terminology that was from when you used to have a battery pack on board your RC to power your servo, your receiver, things like that. We no longer need to do that with these kind of speed controllers. The BEC voltage is the voltage that the speed controller is going to send out to the receiver and thereby power the receiver and the rest of your servos. Okay, unless you have a need and very specific high power servos or receiver, you will use 6.0. 7.4 volts is for high voltage servos and receivers that can handle it. So for the most part, 6.0 is going to run you if you have a need for a high voltage servo for some reason and you can take it, then you can run 7.4. Your cutoff temperature is exactly what it sounds. This is the temperature in Celsius and Fahrenheit that it will turn off the speed controller. The Celsius temperature in Celsius and Fahrenheit, it will turn off the motor. Again, guys, for drag racing, I just max this out to disabled. You can see you have a wide sweep of range, but for drag racing, I disable it. I definitely recommend having something here for on-road guys or buggy guys, maybe 130C for if you're running an on-road or buggy or something like that, maybe even a touch lower if you're not running a stock class. Stock classes are going to get warm. Your mod classes, you should not get this warm, but for drag racing, let's not have anything that can turn off the speed controller. It's a very quick run. Your motor wiring, you see ABC or CBA. Now, I'm going to tell you, this is where it gets a little tricky with these speed controllers, okay? When you look very carefully at it, you will see that it's CBA from left to right. The R1 version is the same, so is the Grapma version. It is CBA. Now, for anyone who's been doing RC for a while, we're going to be used to it being ABC. This is the motor wiring. How are you wiring up the motor? Okay, what ABC means, A to A on the motor, B to B on the motor, C to C on the motor, okay? So it is A on the speed controller, A on the motor, B on the speed controller, B on the motor, C on the speed controller, C on the motor. If by some chance your wiring doesn't look neat or is in a way twisting or interfering, wiring it up CBA like this, all right, you can now flip it to CBA, all right? CBA will be C to the A of the motor, B to the B of the motor, A to the C of the motor. So essentially, it just lines up 1 to 1, C to A on the motor, B to B on the motor, A to C on the motor. This is if you want to swap your wires just because of how it lays out. Okay, I always recommend people do A speed controller, A motor, B, B, C, C to save you trouble. But if you're confident and you feel pretty good about it, you can do CBA. One thing I am going to tell you, if you do change this or you do wire this up, please set your speed controller before you try to power on your speed controller hooked up to your receiver and your radio. If you hook it up to your radio and you try to calibrate your motor before you do this, you will fry your speed controller, guys. So this is very, very important. If you do choose to do CBA and you do wire it up that way, make sure you program your speed controller the way I'm doing it here before you hook it up to your receiver and try to calibrate your radio. You will pop your speed controller. All right, let's get on with now, one thing that you're going to notice that is different about the Yokomo from the R1 is this line right here, voltage limit. Now, voltage limit is a pretty trick thing, and I'm going to try to give you a brief description of how to use it, but I am going to also caution, if you're new, start with it off. All right, voltage limit, you see here 7.5, 7.6, 7.8. All right, the lowest it goes is 7.4. What this is going to do, and it's pretty clever, and it's clever for the Yokomo, and this I would say is more applicable to stock motor classes or buggy, on-road, things like that. The voltage limit is going to be monitoring the power and current draw from the speed controller to the motor. And as the voltage drops, okay, approaching the voltage limit, it tries to make more power by redirecting more current to the motor to make up for the power loss at this lower voltage. If you can imagine, the motor is trying to make a certain amount of power, and power is defined in watts. Watts is voltage times amperage. So let's just say 100 watts is 10 volts times 10 amps, right? But 100 watts can also be 5 volts times 20 amps. This is what the voltage limit is doing. It's trying to keep the motor power consistent so it feels consistent through the run. So again, let's just say this was going down. Let's just say we were trying to make 100 watts and our battery voltage was going down to 5 volts. This would be trying to pump out 20 amps. So 20 times 5 is 100. So we keep our 100 watts, okay? But for the most part, guys, especially drag racing, this will not work. Leave it off, all right? Fan control, auto or on. This is pretty self-explanatory. The fan has an automatic circuit that will come on, or it'll just be on when you power on the speedo. Now, guys, I know there's a lot of people that do not run a fan. I personally think it is crazy to not run a fan. It pulls no power at all. It does not affect your battery. It does not affect your run. Turn your fan on, especially if you're drag racing. But I think for anybody in any RC, just have it on. Have this thing on all the time, because these things will heat soak when you come to a stop. So that time that you come to a stop and you're just going to pick up your car and things like that, it's going to heat soak. When it's on, it'll stay on and it'll really keep your speedo cool. This is not worth it, guys. Run a fan and turn it on. I highly recommend that. All right. Next tab is the throttle tab. And you're going to see here this power curve. And you're going to see that there's a 0 to 10. All right. The way this works is whatever number you leave this on is the curve that it runs. So if you leave it on 0, it is going to run through this curve, all right? And you can see that you can actually see the curves here, and we're going to get into modifying these curves and how we modify these curves after we go through the demonstration. But you see here we're on 10. It would run 10, 0. Now, I'll just really quick describe what this is. This axis here is the x-axis. This axis is the x-axis. This axis is the y-axis. The x-axis is the input from the radio. So this is essentially 0 input from the radio. This is 50 from the radio, all right? So what do we have here? We have the radio signal is at 50% throttle, but the motor power output is at 51. I see this curve is slightly positive. So for 50% radio, we are getting 51% motor power. This is your motor power. All right, I could actually do this if I wanted. I can have 51% radio and 86% motor power. We're going to get into this in a minute, but for right now, understand that this axis is your x-axis, this axis is your y-axis. X-axis is the signal from your radio. The y-axis is the power out. They do not have to be one-to-one, guys. It does not have to be one-to-one. We can have the radio at some input to the speed controller. We can have the motor power out at something else. I'm just going to cancel this, get on to acceleration. Acceleration, in all fairness, isn't all that understood. My best understanding is there's points in between these points, and the acceleration looks to influence how the motor power is being delivered in between these points. But I'm going to give you my absolute best advice and how I found to use this best. I leave it at 5. And the reason I leave it at 5 is I do all of my tuning with the acceleration at 5. Now, when I am done and I am looking for something, just a little bit, I may try it at 6, 7, and see how it does. But I also may say, hey, you know, my tune is really good, but it's weather's changing. It's gotten just a little cold, or maybe I got a little bit of cloud cover. I might want to not change my tune all that much, but maybe I'm just going to knock this down just a little bit. So by having it at 5, and I'm always tuning with it at 5, everything that I've done is pretty much in the middle of the influence of this acceleration number, okay? It's in the middle. So this gives me just a little bit of fine tuning to change, and that's how I use it, the best way I can describe it. Start power is exactly what it sounds. Start power is the amount of power, I'm going to open up this graph, the amount of power that will be initially applied as soon as the radio cracks into this curve, okay? As soon as the radio just crosses over from being neutral to moving the car, okay? It will apply this amount of power right pretty much at this line. And then it will, boom, drop to the next point, whatever is the next point from the radio. So let's just say your neutral is 4%. 4% is going to be somewhere right about here. Your radio will crack neutral, deliver your start power, bang, for just a brief instant to move the car, and then immediately go down to the first point that it reaches and then follow this curve, all right? So start power is very useful in getting the car initially moving. Now, if you're running a stock class car, like a stock buggy or something like that, you may want a lot of start power. Those motors don't make a lot of power. For drag racing, we use this a lot in conjunction with this, but we're going to cover that in the second part of this video when we talk about tuning. But understand for right now, start power is essentially just the initial crack as soon as we crack neutral. Your neutral width, narrow, normal, wide, is exactly what it says. This is the amount of deadband, the amount of play in the radio before it starts to move. I, especially for drag racing, always run narrow because I want the car to move as quickly as possible. And by having it set on narrow, I need just the tiniest little movement in the trigger to initiate coming out of neutral and going into my start power and my curve. Now, maybe for a buggy class, especially a high power buggy class, you may want normal or wide. This may give you just a little bit more sensitivity. But for the most part, I say if you're new, start normal and then try it wide, try it narrow. But I really recommend for drag racing, run it on narrow, okay? Your smooth start and your smooth start range, okay? This is going to be essentially the inverse of timing, all right? This is the range that this is removing power and by this much from the motor. So let's just say you have a high power buggy that has got a pretty low turn motor, and you're just not coming out of the corner without spinning or spinning the tire. You actually can use this smooth start rate, okay, see all the way up to 30. And this is up to this throttle percentage. So if you have it at 31%, it will smooth start, which is this depressed power range, up to 31% of your trigger. And then after that, it is not going to use this. So this is essentially a low trigger range to take power away from the motor just to make it smoother. You can use this in drag racing, but I definitely recommend this for advanced, not beginner. Like I said, your biggest benefit is going to be on a low traction surface like indoor or outdoor buggy, something like that. That's where a lot of people use this, but you can use it in drag racing. Right now, I recommend starting with it off. Reverse. Reverse function. Two-way means that you have reverse. One way is no reverse. I recommend everyone run it one way, no reverse. Most racing series, especially professional RC racing where you're running a buggy or a touring car, something like that, do not allow you to run reverse anyway. But I recommend turning it off. And the reason I recommend turning it off is you cannot accidentally put the car into reverse when you're on the brake. Because one of the things that do happen to people is they're full throttle and then they quickly get on the brake. And for whatever reason, they just creep off the brake and they realize they got to get back on it again. Well, in that process of getting off the brake and back on it again, you can actually engage reverse, try to put the thing in reverse and blow up your transmission. That's what this reverse delay is here, this 2.5 seconds. So at 2.5 seconds, this is pretty big. It's going to be pretty hard, I think, not to do it accidentally like this, but just get used to running it one way. You don't need reverse. If you really do need to have reverse, leave this reverse delay at 2.5 seconds. And this is the amount of reverse power that you have. You really don't need 100% reverse power. Maybe something like 30 or 40 is fine, okay? Okay, let's talk about brake. Here, you're going to see we have a lot of settings: your brake response, drag brake, your minimum brake, max brake amount, your mid brake location, and then just an overall setting of soft brake or hard brake. All right. Your brake response percent is essentially the percentage of brake feel that you're gonna get. You have a quick dial over here that you can use in addition to the slider. I wanted to mention that earlier, but this is going to be really important for your on-road and off-road guys in giving you your desired brake feel and brake response. This is definitely a setting that is going to be driver preferred. I always recommend starting in the middle. All right, you can go up one way, go down one way, and see how that feels to you. Drag brake. This is a good one, and it's actually quite useful for a lot of applications. Drag brake is the amount percentage of brake, okay? It's the percentage of brake that will be applied when you release the throttle and go to neutral. So essentially, instead of just coasting, it will coast and be slowly applying a certain amount of brake, all right? This can help in a lot of different scenarios. For instance, if you're on-road or off-road and you're entering a corner, but some of the corners are tricky and you have to let off the throttle and then maybe just delay how much time you're going to get on the brake. Or maybe there are some corners that don't even need any brake, but they just need the tiniest little bit. What you can do is lift, have just this tiny little bit of brake applied, and then negotiate the turn or the corner, and then get back on the throttle. Now, where this is also useful is in drag racing, and that's anyone who drag races knows that sometimes at the end of the run, we slam on the brakes a little bit too hard, and we can lose control of the car. Well, by having a certain amount of drag brake, maybe 15%, you actually can be full throttle and then just let go. And it'll just gently apply 15, especially if you have a lot of room and you shut down, and just let it coast. And then maybe after it's coasting for, a second or two, you can just start to apply some brake. But this is a nice gentle way to bring in some brake. So tons of uses for this. Like I said, it's very, very useful, especially if you're going to be using the car in some kind of circuit type racing where there's some corners that really just, maybe you're finding that you're just over braking. Even just touching the brake is over braking. You really just need it to breathe off. Maybe it's a high speed, like a double apex corner where you just need to kind of come down, maybe just release and then back on again. A little bit of drag brake could be your friend here. But just be mindful of it because one thing I am going to tell you, this will be applied anytime you let go of the throttle. So especially maybe guys, I did say it could be useful for drag racing, but it could also hurt you if for whatever reason you are on the throttle and then you get off the throttle and try to get back on again. It's gonna apply the brake. If you are very trigger disciplined and you can just hold the trigger and maybe just drive the car if you need to, this can be very useful in the shutdown by just letting go of the throttle and letting it just gently drag the brake. So your minimum brake amount is exactly what it sounds, the minimum brake amount. So this is 30% brake is the absolute minimum that will apply. Remember what I said about just that little feel of your brake? Well, if your minimum brake amount is maybe too high, anytime you just touch your brake, you're going to be applying this much brake. I personally like to run my min brake amount at 0, but on my on-road or off-road cars, I may have it like at 5, just to help me with, just like that little brush that sometimes that I want to do. But I really like it at 0 for almost everything I do. But remember, guys, if you apply 1% brake and you have this at 23%, it'll apply 23% as soon as it sees any brake. So keeping it 0 isn't really going to hurt you. I really think that this is an advanced feature and it's really a feel thing. And I see it more for on-road and off-road guys than I do for drag racing. I really think for drag racing, you should keep this down. I do personally use a little bit of drag brake. I use about 15% of drag brake for drag racing, but I have my min brake amount at 0. Now, your maximum brake amount is also exactly what it sounds like. How much braking power will you apply? All right. I will always leave this at 100. Okay. And if I think I need less, I will command less in my radio. All right. I will command less in my radio. I will set the radio dual rate. That's exactly what it means. It means that you have a second rate that you're choosing that is going to override your primary rate. All right. So I'll do this in the radio, but if you don't have a radio that works well, or things like that, there's nothing wrong with doing it here. The only thing about doing it in the speed controller is once you're on track, that's what you got. You're never going to get more. Where with your radio, if you had a dual rate and you have a little dual rate knob or a switch, you can easily click it up or down, and your speed controller has 100%, and you're just commanding how much you're using through your radio. So me, I like this at 100%, but if you know what you're doing, you can set it to less. But I think it's just it's a really good habit to start at 100%, especially if you're new. Your mid-brake amount and your mid-brake location kind of work together. Right now, this is linear. Our mid-brake location is at 50%. That's 50% of the brake travel is our mid-brake, all right? And our mid-brake amount is basically linear. So we're going from minimum of 0 to a maximum of 100, and we're just saying 50% is right in the middle. So we have a straight line of braking. But guys, we also don't have to have this. We can have our mid-brake location something higher, and this may give you a little bit more feel at those low braking percentages, because guys, let's face it, it's pretty hard with your finger to go boom right to 50%, right? Especially when you're trying to do it quickly. You're probably going to overshoot. So there's a lot of value maybe in setting this higher and even working with your mid-brake percentage so that you're staying within a lower braking percentage range across this range of motion. And then you just, when you go full brake, you have 100. This personally how I like to do it. I don't really I want to know that if I really needed 100% brake, I have 100% brake. That means I'm just going to mash the brake setting on my radio all the way. But I will typically run a higher mid-brake location and a lower mid-brake amount. And all this does is it takes 0 to 75% brake travel and, makes it like 0 to 40% brake power. And then after 75%, it ramps up really quickly to 100. Again, this is a feel thing, but I'm just explaining how to use it. And then this hard brake, soft brake, there's some settings in the background that are how it applies the brake, and this is contributes to the overall feel. I'm personally a soft brake guy. I like soft brake, so I leave it on there, but I would encourage you to try hard brake and see how that works for you, especially maybe you got a very high turn motor, a 21.5, 25.5, something like that. Okay, everyone, we're back, and now we're on the frequency tab. So you're going to notice 3 different sections: your brake frequency, your motor frequency, and your drag frequency. Your brake frequency is the frequency that's applied during braking. Your motor frequency is the frequency that's applied on power, and your drag frequency is the frequency that's applied during drag brake. So what is frequency? Why do we need to know about it, and what does it do? Well, let's start with what it is. Frequency is a unit of measure of, hertz, is a unit of measure of frequency. So 1 hertz is 1 cycle in 1 second. So a cycle is 1 on and 1 off for these motors. So 1 hertz is 1 cycle in 1 second. Hertz is the unit of measurement for frequency. Okay, so this is kilohertz. 1 kilohertz, that's 1,000 hertz. 5,000, 1,000. Okay, well, what does this mean? Remember, we said 1 hertz is 1 cycle per second. So that's 1 on, 1 off. All right, now the thing that never changes, okay, is the block of time. Okay, it's 1 second. All right, so essentially, This is how many frequencies we are going to see in 1 second. So this right now is 5 kilohertz. It's 5,000, 1,000, 1,000. All right, well, what does all this mean? Well, I'm going to explain. Because we have 1 second of time, okay, we are fitting 1,000 blocks. Let's just pretend that these are blocks. We're fitting 1,000 blocks into 1 second. Well, imagine instead of blocks, we're talking about rocks. And let's just say that these are large rocks. The lower the frequency, okay, the lower the frequency, the larger the blocks are, okay, because we're fitting less of them in 1 unit of time. All right, we need to think of it as how much we're fitting into 1 unit of time. So let's go back to our rocks. Let's pretend we have a bucket, and the bucket represents 1 second. We can only have 1 second of time, and this, let's just say 1 gallon bucket represents our 1 second of time. Well, if we had large rocks, which represent the low frequency, and we had tiny, tiny little pebbles, which represent the high frequency, all right? Well, it's pretty easy to understand that in our 1 gallon bucket, which represents 1 second of time, the large rocks, we're not going to be able to put as many in before we fill up that 1 gallon bucket. The same way, we can only get 1,000 of these on blocks in 1 second frequency. But now when we go to 32,000 hertz or 32 kilohertz, we're fitting in 32,000 of these blocks in 1 second of time. So they're just like tiny little pebbles. We can fit way more of them in the same 1 gallon bucket or the 1 second unit of time. So what does this mean for us? Well, just like those little pebbles, right? There's a lot more of them, but they're smaller, okay? Now here, there's a lot less of them, but they're bigger. So think of it as how the motor is being, how the power is being applied to the motor. It's these big coarse blocks, bang, 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 like that, or these tiny little blocks, tick, 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 tick. Think of it like a fine Swiss watch, tick, 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 ticking, right? It's going to be a lot smoother with high frequency, all right? It's going to be a lot coarser with low frequency, but the low frequency will actually produce more power, all right, because it's more efficient. It produces less heat, it's more efficient, and we have these larger blocks of energy. Think about pushing a car. If you ever had to push a car, you can make really hard pushes, right, to try to move the car, or you can sit there and just kind of tap, 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 tap on the car. Well, guys, I think it's no secret that it'd probably be very difficult to actually get it to moving with a whole bunch of light little taps. But it probably would be okay to keep it moving with a bunch of little taps. And this is the trade-off that we have. Do we use these big hits of energy, or we use a lot smaller ones? Now, my best advice to you is use the lowest number that you can get away with, okay? The lowest number that you can get away with. Understanding that as we go up, it is going to be smoother. There is less power to be made. I'm just telling you, there's no way around that. Ultimately, if you were to put this on a dynamometer and run the motor at 1 kilohertz and run it at 32 kilohertz, the motor at 1 kilohertz will produce more power. We do have a danger of burning up the speed controller at this high of rate, especially when we're asking for a lot of power, because we're trying to fit 32,000 cycles in 1 second. And if we're asking for a lot of power, a lot of current, a lot of things happening, and we're trying to do this 32,000 times in 1 second, well, that's going to produce a lot of heat and it's going to cause a lot of inefficiencies. So The absolute best advice is run this as low as you can. That produces the results that you're looking for. I'm just going to give you a quick tip. 8 kilohertz is a really good place to be for drag racing. I definitely would say that you're going to be plus or minus maybe 2, 3 at the most. You know, maybe 12. Maybe your range is going to be 12 to 6, 12 to 5 at the lowest. But 8 is a really good place. If you are running a mod buggy or an off-road buggy or something like that, an electric motor is really powerful. You know, maybe 5, 6, 4 are your friend. But if you're running something like a very high turn motor, 21.5, 7, even 17.5, you're probably going to want this to be, oh yeah, this is going to give you the most punch. We probably hear people say that term, punch. How much energy are we hitting it with? That's going to happen here. But the same also happens during brake. Okay, low kilohertz are going to be give you that feel of very aggressive brake. It's going to be on the brake, on the brake, on the brake. So there is some advantage to running this. I wouldn't recommend running it too high because essentially you're going to feel like you have no brakes. But you know, something maybe 3, 4 kilohertz is maybe a good place to start on the brakes. Like I said, my best advice if you're drag racing, start at 8. If you're on-road, off-road, high-power motor, you know, maybe 6, maybe 6, 5, something like that. And then if you're running a really low-turn motor, really high, low-power motor, you can run it down here. So that's what this does. Now let's get to boost and turbo. And this is probably the thing that most people have a hard time grasping. So right now we can see that it's off. And I am going to say that for every speed controller, this works a little bit differently. Today we're talking about the Yokomo R1 Gropner speed control. They all work exactly the same. The app is exactly the same. So we're going to talk about this in other videos. We'll get into how you do this on other speed controllers, but the concept is always going to be the same. So right now you see boost is off. So we are going to turn it on. And you see we have off, we have something that says boost right here, okay? We have something that says throttle, and we have something that says auto throttle. Now sometimes this is just referred to as auto, boost auto. Here it says auto throttle. It's really just indicating what it is. We'll go over that in a second. But this is the 3 basic versions. Now, you are going to see we have a box here, one here, and one here. All right. The way it works on this is we highlight the box that we want, and we're going to get a slider, okay, or we can move it gently with the plus minus arrow. So for the sake of what we're doing, let's just say 20 degrees of boost, and let's just highlight turbo, and let's just say 20 degrees of turbo. All right. So right now I got 20 and 20. Now, if you look here, you're going to see a number, 5,000 and 25,000. What this means, this is the RPM range. The RPM range that will apply your boost timing, okay? Boost timing is, in the RC world, the convention for boost is timing that is applied over some rate that is below full throttle, okay? What does that mean? That means that this timing is going to be applied, okay, either via an RPM range or from 0 to 100% throttle, okay? It is generally understood that we are using boost timing below 100% throttle. Now, I will tell you that may not work out if you use the RPM method. If you use the RPM method, you could have this crossover where you are reaching full throttle before you get to the end of your boost range. And I don't really advise overlapping your boost and throttle for any form of RC. All right, and we're going to talk about how to tune all that as soon as I get through just explaining what all this stuff is. So, but for the most part, boost timing is timing that is applied across some range. All right, that's about the best way I can describe it. Boost timing is timing that is applied across some range. In this case, the range is a throttle range, or, an RPM range, I apologize, or a throttle range, all right? But let's just talk about RPM right now. So this is where we use our data logging to kind of understand how we're working. But just like we change these, we change this. Now, let's see what happens when I go down to 0. When I go down to 0, you can see the slider moves. Why does it move? It moves because at 0 RPM, as soon as the motor starts, it'll start running this 20 degrees across this ramp. All right? Now, let's say I don't want it to start at 0. I want it to start something later. Okay? I want it to start at 10,000. So now the motor is at 0. The motor starts spinning. It gets to 10,000. At 10,000, we start applying timing. The rate at which we apply timing is the slope of this line. Let's say this is too quick, all right, and we're losing traction. We can now slide this over, all right. I'm just going to max it out to 65,000. What have we done? Now we crack the throttle, the motor starts spinning, it reaches 10,000 RPM, all right? At 10,000, we start applying timing, all right, all the way up to 65,000, which means that 20 degrees is going to start here at, 0, 1, right, degree of timing, and it'll finish at 20 degrees over here. Along the way, it's applying timing evenly spread across this number. This is something that the speed controller does automatically. All right. Now, I'm going to tell you some issues I have with RPM-based timing only. All right. I figured I'll just do it while I'm here. One of the issues I have with RPM-based timing, whether it's for drag racing, on-road, off-road, anything like that, is it has no other gate. It is the range of boost timings. Remember, boost timing is timing that is defined as being applied across some range. In this case, the range is RPM, but the range could also be throttle. But the problem that I have is there's no gate to this. And what that means is there's nothing else as a condition or a qualifier for this boost timing. So, guys, let's pretend this is our motor RPM. And the motor RPM is going up this way. We're applying 0, 1, 2, 3, 4, 18, 19, 20 degrees of timing. Well, what happens when we're over here and we lose traction and all of a sudden the motor RPM whizzes up? Well, guess what? The speed controller is not smart enough to know that we lost traction and the RPM just shot up. It just says, oh, I'm 1,000, 1,500, 15,000, 20,000, 25. Oh, I'm 65,000 RPM. It will apply the full 20, boom, right here, okay? Which is going to make your traction problem worse. Now, not only did we lose traction, but we actually added way more power while we're doing it. This is just going to make the problem worse. If there was a way to hit a cap, right, like across some throttle range, where no matter what happened to the RPM, as if we were under like these qualifiers, it wouldn't apply. That would be a lot better in my opinion. So if you manufacturers are listening, this is not really a perfect solution. We really should have some kind of cap that, ideally it would be ground speed based or something like that, but we don't have that with RC cars. But at least have some throttle position qualifier. So let's just say I was at 50% throttle here, and at 50% throttle, I didn't want any more than 10 degrees of timing. No matter what happened to the RPM, if I was at 50% throttle and the RPM shot up, it would be just locked at 10. It wouldn't apply any more than that. When the RPM dropped or my throttle percentage went up, then I would be able to apply more timing. But you can see the problem here, because like I said, if you were coming out of a corner, boom, you're accelerating and your motor speed is picking up, you lose traction, all of a sudden, whoop, your RPM shoots up because you lost traction. Well, if it shot up to here, it's going to say, oh, 65,000. Let's apply full timing. That just makes your traction problem worse. Okay? So for that reason, especially for drag racing, I know a lot of you guys are probably watching this, you want to know about drag racing, but I'm trying to cover all forms of RC. Especially for drag racing, I like to use the throttle and the auto throttle method. Now, if you see here, we had our 20 degrees of boost. We switched to auto throttle. I'm going to start here because I think it just works better. We switched to auto throttle. What this means is it will auto linearize our 20 degrees of boost timing from 0 to 100% throttle. All right. The speed controller will evenly spread this 20 degrees from 0 to 100%. Okay. So at 50% throttle, you will see 10 degrees. All right. At 100% throttle, you'll see the full 20. At 0, you're going to see 0. All right. At 10% throttle, you're going to see 2. At 20% throttle, you'll see 4, so on and so forth. Okay. It is linear. And this will do it automatically. So no matter what we do to this number, all right, I can make it, 38 degrees, some oddball number. The ESC computer will auto-linearize it from 0 to 100% throttle. Now, this is radio throttle, guys. This is the signal coming in from the radio. The signal going into the radio, this is using the signal that's going into the radio, okay? 0 to 100% radio throttle signal, all right? Radio throttle signal. Now you see we have something here that says turbo, okay? Turbo, we can go up, we can go down, we can go wherever we want, but let's just play around with the number, all right? 30 degrees. On this speed controller, this is where we set the turbo function, okay? This is where we set the turbo function. We set the amount that we want here, and we will hit OK. All right, you have to always do your boost in this page, and you always are going to set the amount of turbo you have in this page. Now, you see I went to throttle, and you notice I have a bunch of zeros here. The throttle function is this, auto throttle, but it is defined by the boxes we set, okay? So I'm going to do it very simple and just give you an example. Let's just pretend we wanted 10 degrees here, all right? And I'm going to show you something. So we have 10 degrees and 10 degrees, all right? 10 degrees boost, 10 degrees turbo, all right? Auto throttle. What does that mean? It means as soon as we pull the trigger, the speed controller is going to auto linearize this throttle number, this boost number across the throttle. So 10%, 1, 20%, 2, 50%, 5, 70%, 7, 80%, 8, 100%, 10. Okay? Why we use this? Because it does it automatically. You don't even have to think about it. It just does it automatically. But it kind of works for odd numbers. Let's just say 12. All right, that's going to be 1.2, and then 2.4, blah, 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 blah. All right, so this is pretty handy to get an idea of what you want very quickly. Now, after you go through here, let's just say you want to start fine-tuning it. Well, I'm going to basically kind of start the tuning concept of this now just because we're here, and I think it's we've already discussed how all this works. Let's just say in testing this method with whatever we're doing, we find that 10 degrees is working for us, all right? But we don't know, are we leaving anything on the table? We don't know. So your next option is to go here, recreate your linear throttle, okay? Recreate it. Now, guys, I'm doing this very simple and basic. Sorry, just to demonstrate it, okay? All right, now if you see what we did, all we did is take this auto throttle, 10 degrees, and we defined it by these boxes. All right, now we have boost by throttle. The computer in the speed controller will no longer linearize it. It will do exactly what it says here. It will only linearize between these 2 points. Okay, so 10, when it sees 15, it's going to use half of this, which is 1.5. 30 to 40, if you're at 35, it will use half, 3.5. So on and so forth. So the points in between, the computer will linearize, but it will use this number at these specific locations. What does this mean? It means that we can command something that's not linear. So let's go back to our example. Let's say we liked 10 degrees, but who knows? Maybe we can take 10 a little bit sooner. Maybe we could take it at 90% throttle. Maybe we can take it 9 at 80. Who knows? Maybe we can even take the full 10 here, right? Maybe we can take 8 there, right? Maybe we could take 7 here. Right? This is one of those things you're just going to play with and see what you can take. You're going to usually take. But here's the other thing. Let's just say maybe this is too much. Maybe even this is too much, right? There's nothing saying you have to go up. You can also go down, okay? See what we did here? We kind of like have a little bit depression and we kind of come up. This is how you use this. You will use this to fine tune, but basically we've already figured out from our auto throttle, and we kind of like this number. We like this number, all right? Do we know that it has to be 10 here? We don't know that, but this is what we're gonna do in trial. But this is how you use this box. So this is called the boost box. You may hear people talk about adjust your boost box. This is what they mean. This is the boost box. When they talk about adjusting your boost box, this is what they mean. Okay? Your turbo is still adjusted from here. You're always going to do your turbo in any one of these boxes. Okay? And then we're going to finish the turbo in the next page. So let's just say we liked this number. Our data says that we have a lot of traction, things like that, but maybe we're struggling just a little bit down here, but we seem to be pretty good up here. So maybe we're going to try something like this. This is just a suggestion, all right? So we've already said this is good. We're trying for something like this. We're going to hit OK. Now you're going to see this page here. This is telling you what you have. You have 10 turbo. You have boost plus throttle. It shows you the box. Now, if I was to go to auto throttle, you'll see it tells you. So this is basically telling you what you have. You have auto throttle. You got boost by RPM. And you see that it changes. All right. So for the demonstration, we're going to do boost by throttle. We're going to hit OK. All right. Now, you see here, there's something that says turbo delay. And there's some numbers that go there. The turbo delay is the amount of time in seconds that the turbo is delayed after reaching 100% throttle from the radio. So, you go and pull the trigger. Now, if you're drag racing, especially if you're drag racing, you're using a throttle delay. That means in your radio, you have delayed the amount of time. You pull the trigger immediately, but the radio is applying throttle at some rate that you prescribe in your radio. That's very common for drag racing, okay? Not common for any other form of racing, except for drag racing. I'm not saying that there might be some value in slowing down the throttle speed in other forms of racing. There probably is. But for drag racing, it is essentially priority number one. So for the sake of drag racing, we're going to understand that we snap the trigger. And just because we snap the trigger, the radio is outputting some throttle signal over some period of time. So it's, 10, 20, 30, 40, like that, right? And that corresponds to this number, okay? When you snap the trigger on the radio and the radio is outputting 10, 20, 30, 40, it's whatever speed that you have in your radio, it's going to say, okay, 30, 40, 50, and it's going to apply these boost numbers, linearizing only in between the boxes, all right? But when it reaches 100%, it is waiting for turbo. If you have zero delay, the very instant it hits 100%, it's going to start ticking off your turbo. But let's just say we think we want to delay it by a little bit. Now what happens? The radio shoots through its throttle range. It hits 100. The speed controller sees 100, and it will wait 1/10 of a second before it starts applying turbo. All right, if you put it down here, it's going to be 0.05 of a second, 0.15 seconds. So that's 0.15 seconds, 0.2, quarter, right? Whatever you want. My best advice is to kind of start this about 0.05. I always like to give the speed controller just a little brief over a period of time that it's transitioning out of boost and into throttle. So I typically run for drag racing here. For on-road or something like that where I'm using turbo or buggy, I may actually set this a little bit higher, because generally what happens is you enter a corner, you're on the brake, you're on the throttle, and you're just starting to come out of the corner. And really what you want is the turbo to kick when you come out of the corner and you're just going straight, okay? You really don't want your turbo to start kicking while you're just relaxing the steering wheel or unwinding the steering wheel, because you could spin out. So this is really helpful to, turn the corner, boom, hit the throttle. The buggy is just, or the, whatever, the on-road truck or, your short course truck or whatever it is, on-road car, is just exiting the corner. It's just going straight. Boom, the turbo hits and it goes. So this is why it's valuable, okay? It's really valuable because it can help you just nail the trigger and go. But for drag racing, I'd probably say that we are going to keep this pretty low, all right? I'm not saying there isn't a value in increasing it. And matter of fact, there is a tuning aid that we're going to talk about when we talk about advanced tuning using it, but this is essentially what it does. All right, so let's just say we set it to 0.5. Now, the next thing that people don't fully understand is what the turbo positive slope does. The turbo positive slope, okay, is the amount of time it's going to take to apply 10 degrees of boost, 10 degrees of turbo, okay? This right here and this work together. So let's say for the sake of argument, we set the turbo positive slope to 1 second. That means it will take 10 degrees of turbo and divide it by 1 second and apply 10 degrees over 1 second. So what does that mean? It means that every 1/10 of a second, it will apply 1 degree. So this will go 1 degree, and then a tenth of a second, another 1 degree, another tenth of a second, 1 degree, another tenth of a second, until it gets to, 5/10 of a second, 5 degrees, 1 full second, 10 degrees. But let's say we want it to come in quicker. Let's say the data says to us that it can come in quicker. Now, let's just say we set this to half a second or 0.50 seconds. Well, this means that our 10 degrees, instead of coming in at 1 full second now, we'll get 10 degrees in a half a second. So that means that every 1/10 of a second is now applying 2 degrees. So 2, 4, 6, 8, 10. Just like that. Every 10th of a second, it's applying 2 degrees. Let's go even quicker. All right? Let's do it in a 10th of a second. Now, we're applying 10 degrees across 1/10 of a second. So every 1/100th of a second, it's applying 1 degree until it reaches a tenth of a second. We have our full 10 degrees in. Okay? That's how your turbo positive slope works. It's the amount of time it takes as soon as you reach full throttle for your turbo to come in fully. Now you have something called your turbo minus slope or your negative slope. This is the amount of time it takes to bleed this off or to unwind your turbo. Now, guys, I'm going to let you think about something, especially for the drag racing guys, but it is applicable for on-road and buggy guys. If your turbo positive slope for drag racing is set too quickly, let's say to 0, this means the very instant you let go of the throttle, all your turbo is gone. And if you get back on the throttle, you need your turbo positive slope to build it back up again, okay? If your turbo minus slope is set to 1 second and you come off the trigger and then back on again, you'll only lose the amount of turbo for that brief period of time that you were off the trigger. All right, now if you're off the trigger for 1 full second, which actually is quite a lot of time, you'll lose all of it, okay? But if you're, on, off, on again, right, you won't lose all that much, and then your turbo positive slope will build it back up. But if you're down here and you just get off for any reason, turbo's gone, just like that. So for drag racing, I just max this out. But guys, I am going to tell you, timing, especially turbo timing, does affect your braking. When you have a lot of timing applied, your braking performance is not that good. All right. So for on-road, for buggy, dirt off-road, something like that, you may not want this to be really high. You may want it to just be, like a tenth of a second or something like that, because it does affect your braking. You'll go to brake and you actually won't have the same braking performance or feel that you want. But that is how you use your turbo negative or minus slope. This essentially is how quickly it will bleed off the turbo, and the turbo positive slope is how quickly it will stack in your turbo. All right, that's it for boost and turbo. Let's get into advanced tuning. Okay, everyone, let's dive into some advanced tuning. So now we have a really good understanding of what the settings and the parameters do. Let's put it all together into something that is meaningful. So the focus that we're going to talk about right now is going to be more towards drag racing because I really believe that this is the more complicated concept that people are asking for and the questions that I get asked most often. I will say that all of the concepts that we're going to talk about and the ideas are applicable across all forms of RC. We're just going to tailor them a little bit differently, but the concept will be the same. Like I said, the main focus we're going to talk about is geared towards drag racing because that's really the discipline that we're using the most of these tools. So let's dive in. So we've already are assuming that we've gone through and we've set everything up correctly as per earlier in the video. So the main focuses that we're going to be looking to tune is going to be the throttle curve, motor frequency, and our boost and turbo. All right. So I'm going to tell you that I'm going to give you some recommendations that are going to be both for dry tire RC drag racing and prep RC drag racing. Now, my recommendations are just a start placeholder. All right, these are not going to be your final perfect numbers, but it is a really good place to start. And I will tell you, you actually should be able to achieve some pretty decent results. One disclaimer that I am going to talk about right now is that when you guys buy your motors, this is a pretty hot topic, especially for RC drag racing, but when you guys buy your motors, whomever you buy your motor from, you really need to be getting good data from them. And that data should include a suggestion for gear ratio, okay, your FDR, your final drive ratio, your suggestion for maximum overall timing, which is going to be a combination of the end bell, the static motor timing, so the timing that's physically in the motor to begin with, and the amount of extra timing that you should be applying. And you should also be getting a idea of a useful RPM range, okay? I can 100% tell you that I test a lot of motors. I've tested every single one. I test them very thoroughly, and there 100% is a range of RPM that works best. And once you're outside of that range, your performance falls off considerably. So if you're not getting your static end bell timing, the recommended FDR, your maximum timing that should be applied motor plus ESC, so your dynamic timing that is going to be applied in the speed controller, you need to be getting those numbers. They're very, very important. And finally, you need to get a very good range of RPM that you should be looking for. Why the RPM range? Because that is going to help you final hone in on your FDR. All right, you should get a start FDR from whomever you get your motor from, but you are going to need to know what RPM range you should be targeting so you can fine-tune your FDR. And we're going to get into how to figure out your RPM range when we dive into the data log part of this video. Okay, but these are the questions you should be asking and you should be expecting. We here at GK Systems and RC Street Wars always provide this information. We've been known from day one to be the leader in providing customers with the very best information so that they can make the most informed decision. We have decided to make these videos now free for everyone so that every one of you guys out there has the benefit of improved performance, success, and just getting better use out of your RC experience. So that being said, let me get into my recommendations for both dry tire and for prep racing. So for dry tire, I am going to recommend that you use auto throttle to start and 10 degrees of boost and 10 degrees of turbo. Now, maybe some of you out there are thinking, wow, that's not a lot. I can tell you, I have been 1/8 on the GNSS dry tire with exactly this. Very, very simple tuning. Yes, there was a little bit more in the speedo and a little bit more in the radio that went into that, but this here has produced a 1/8 GNS at pretty mid 70 mile an hour range. So nothing exciting mile an hour, but the ET was good. So I know that this is a good place. All right. For your prep, I am going to recommend a (30-20). Okay. For prep, I'm going to recommend 30-20. Now, why the difference? I'm going to explain. All right. Remember, this is just the start. All right. Let's talk about dry tire. When we use these numbers, we are going to be assuming that we are using a throttle speed delay in the radio. That throttle speed delay in the radio, I'm going to recommend start at something that is going to give you a 1.2 second time to full throttle. Okay, so that is going to be from the very minimum EPA to your maximum EPA in your radio at around 1.2 seconds. Now, for a Sanwa M17, which is probably the most popular, that is going to be a value of a -96. Okay. For you Futaba guys that are out there, that's going to be a value of approximately 21. All right. I'd probably say if you're a Futaba guy, start around 21, 22, and that should be a good place to start. I also do recommend starting off with just a 2-speed on your Futaba, so that's going to be a low and a high, which is very similar to how the Sanwa does it with the point and the speed, but that'll be another video. But if you're familiar with these terms, you want to be doing -96 on your M17, and let's just call it a 22 on your Futaba. All right, so what's going to happen? All right, we're going to pull the trigger. There's going to be some delay in throttle, and your boost timing is going to be applied across the throttle range. Okay, after we hit 100% throttle, turbo will kick in. All right, now guys, the prep car will have, why we're doing this is that this is going to limit the torque. When we pull the trigger and we have this throttle speed delay, the 10 degrees of boost is not going to produce that much torque across the run for the dry tire. The 10 degrees of turbo will come in after full throttle. We already got enough speed. But for the prep guys, we have to remember one of the advantages to prep is increased traction. One of the disadvantages of prep is that it eats motor power, okay? It requires so much more power just to overcome the glue that's on the tire and the road. That sticky substance that's on the tire is resisting turning, right? Essentially, it's like trying to push a car with a flat tire. It is resisting turning. It eats a lot of power. Therefore, even though we're at the same throttle speed, we need to apply significantly more torque when we are running on a prepped surface, okay? And even when we're into the turbo, all right, even though we're at full speed, that glue that's on the tires and eventually on the surface is looking to slow the car down. Essentially, it is adding resistance. It is adding resistance, okay? The more prep we run, the more resistance we're adding, the more load is created, the more power we need just to overcome that. So in essence, you're using your 30-20 and ultimately getting about the same as your dry tire 10 and 10, just because we need to overcome this resistance that's looking to slow the motor down. So for prep, I recommend starting auto throttle 30-20, for dry tire 10-10. So we're just going to hit OK, and we're going to accept this, all right? Now, I'm going to set a turbo delay of 0.5, all right? And I'm going to set a turbo positive slope of 1 second, all right? I'm going to tell you that this is really slow, especially for a prep car, but we're going to get to how to speed this up in a second, all right? What we want to do, and what I highly advise, is to start a lot. There's going to be very few instances, I may talk of a couple, where we're going to be in the middle, but for the most part, your best tuning strategy is going to be to start at some end of the spectrum. And the reason is, when we are here at 1 second, the slider does not go any further. That means the only direction we can adjust this is this way. If we start here in the middle, it's a guessing game. Do we go this way? Do we go this way? We don't know. When we're here, all the way at the end, we're going to run, and this is going to produce some result, okay? It's going to produce some result. Now, when we change it up a little bit, all right, it will produce a different result. What I like to do is make changes in some order of magnitude that I can half the change, all right? So because this is 1 second, the next step I would change is to put this to 0.80. Why? Because if 1 second was good and 0.80, let's just say, is not good, well, we are probably safe to assume that somewhere in the middle is a happy medium. If this was good and this is not good, somewhere probably here is pretty good. And then we have the opportunity to half that again. We can go this way, we can go this way. So I like to make changes in a way where I can half it and find the result. But for right now, let's just pretend we're running a prep car and we're running 30-20. If this was a dry tire car, these would be the same, 10 and 10. My turbo negative slope, I'm going to max out to 1.0 because I really don't want to bleed off any turbo if I have to get off. So I'm going to hit save. If you do not hit this button and you do not see save complete, you have not saved your settings. So you must hit this button. You must see save complete. So the next thing we're going to do is go to our throttle page. What I recommend here is start at your zero curve. Now, I'm going to tell you, this curve is way too gentle, all right? For really, if our RC car is working good, this should be way too gentle of a curve. Now, I'm going to give you my method for setting this curve, and I'm going to show you how to manipulate it. And we're going to start low and work our way high. And the lower ones will be more applicable to dry tire. The higher ones will be more applicable to prep. Okay. So the first thing I'm going to do is delete these dots. Okay. This button here, the trash can, will delete the dots. I'm going to start with the line perfectly straight. And when you delete the dots, it just makes the line straight. You don't have to worry about trying to make it straight. Now I'm going to hit this little plus and I'm going to add a dot. Okay. Now I'm going to go back over here and hit the plus and hit it again. And it's going to add another dot. So you see, it just added a dot in between the two. Then I'm going to do one here and hit the plus sign. Now you see it added one in between these two. Okay. Now I'm going to show you, and you see that it's a linear line, 74, 74. This should be 49, 49, 24, 24. This is just a linear line. Okay, now if you remember from earlier, this here is the radio input signal. This line, this x-axis line, is the signal from the radio. So this is 0. This is 24% from the radio. This is 49% from the radio. But in this curve, the radio signal and the motor output do not have to be one-to-one. They do not have to line up, okay? So for dry tire, I like to start somewhere around 15. Now, I'm going to make you aware of something. You will see that there is an order of magnitude of about 10 points that change every 1%, okay? 10 points that change every 1%. So 41, 42, 43, 44. Now, see this 144? 14%. It just turned. Now we're going to add 10 points to that. So it's 154. See? 154, and it clipped over to 15%. Okay? For dry tire, I'm going to start this first point at 15%. What does that mean? That means I'm no longer starting at 0. My 0 from the radio would equal 15% motor power. So this would be the same as if I was starting my radio at 15%. Okay? But it just gets me to start to 15% a little bit sooner. All right? Then I'm going to take my next point here. See, this is at 24% radio. It's 24% x-axis. And you can use this slider here to slide it one way or the other way. All right? Now, what I personally like to do is set this to the next one to 10 for dry tire. Now, I'm talking about dry tire, and we're going to talk about prep in a minute. I like to set it to 10%. So what I'll do, all right, see here, 102, 9%. All right, now I'm going to add a little bit to this, and you see it's 106. Keep going. You see it changed over at 112, all right? changed over at 112. Now, this is just a little bit of time I need right now so you can understand it. 102. The next changeover was 112. What I like to do is set it in the middle of these two. Because it is 10 points, I will set this to a 107. All right. So I got 107, but I'm still 10% throttle. But I'm in the middle of this little range. Okay. Every 10 points here is 1%. So you see if I go another 5, I get to the end of here, and then it goes to 11%. So for everything here, I'm going to try to be in the middle. So I'm at 107, all right? Now, the next thing I'm going to do is I'm going to make this point and this point equal, all right? So you see here that this is 154 on my y-axis, okay? The x-axis is 0. Now my x-axis is 107 or 10%. My y-axis is 24. I'm going to set it to the same y-axis. So that was 154. So I get close with the slider, and then I'll use this. All right? And we're going to get to why I do this in a second. Okay? This is called a dead band. All right, and why it's a dead band is because the band between here and here does not change. So we call it dead. It's a dead band. So from 0 to 10%, we have no change in motor power. All right. Then what I like to do is get some kind of a radius. Okay. Some kind of a radius that helps me smooth out my transition. So if you notice that this is 10 radio, 15% motor power. Then I just start to smooth out my transition. Now I'm at 20-20. So 20% radio, 20% power. All right. And here you can see that I am slightly depressed from here. My motor power is 26. My radio is 28. So I am going to bump this up a little bit. Okay. So now I'm 20-20 and 28-28. Now I've created a linear line from here to here. All right. So why we do this, I'm going to explain. What I like to personally do is I'm going to use Sanwa talk, but it's the same for the M17 because there's a point. When we talk about a point, this is the point is going to represent a distance that we ignore the throttle speed. So if we were to set a point of 10 and a throttle speed of minus 96, the radio will go from 0 to 10, ignoring the throttle speed. So it'll do it at full speed, which is pretty much instant. So it'll instantly go to 10, and then the throttle speed delay will start at that point. Okay? So from 10 to full throttle, you'll have your throttle speed delay. But because we put this dead band in, between 0 and 10, we have 15% motor power. This is like the equivalent to setting your point to 15. So now, if we had a straight line, right, and we set a point to 15, it would be the same as this, but it would be further over here. See what we're doing? We're working on a target that's going to allow us to change the rate that we get to full throttle. All right. So what we've done now is we've gotten right to a number that we can jump. So I always recommend a point of 6 on the radio. And I tell people from 6, work your way up to 10. If you get to 10 and you're okay, and you're launching okay, then you just bump up these numbers, all right? And I tell people just do it uniformly, add 5 points to these numbers uniformly and move it up, all right? And then bring your point back down to 6 and then work your way back up to 10. But the truth is, if you're going higher than 10, you should just move these numbers up because you're already up here in the curve. Now, it's maybe a pretty good test to just bump the numbers up and see if you can take it. Then you could figure you can maybe move these up. But for all intensive purposes, if you are using a point between 0, let's say 6 and 10, you're going to be working somewhere here in this dead band. And if you make it all the way out to here, you might as well just bump all this up, all right? Now I'm going to show you one more trick. When you have your red dot highlighted here, add one more, okay? This will be the second part of what you're going to do with your throttle curve. So now we are playing with our radio and we're playing with the point. We're finding how high can we bump this curve, all right? And we're going to determine that by how we look at the data. But we're going to look at what we do with this curve, okay? After we figure out where we want to be with this curve, we have one more little trick that we can do, all right? We can take this and slide it over to here, okay? And up to here. What have we done? Well, now we've changed the slope of this line. So the change in Y, the change in motor power, is greater for every change of X. So for every radio input, we're actually seeing slightly more motor power, slightly more motor power. Now we're reaching 100% motor power at 88% radio. So by the time the radio gets to 88%, we're at 100% motor power. We've effectively got to 100% motor power 12% quicker in time, okay? 100% motor power, 12% quicker in time. If we were to make this 90, we would be getting to 100% motor power, 10% quicker in time. But let's just say we like 88. Let's just say testing, we like 88. All right. Now, you're going to say, Gary, why would I do this? Well, I'm going to explain why we would do this. It's because we use boost and turbo, and we have boost and turbo by Throttle. For drag racing, we're going to use by Throttle. Now, something that maybe a lot of you people don't know, maybe even people that are more experienced, I'm going to tell you something maybe you don't know. You know how we talked about our throttle and our boost? Well, guess what? I'm going to save this. Just pay attention to this. We're at 88% and we got this curve. Now, this is dry tire. Prep is going to look different, but this is dry tire. This is about, something we're going to play with for dry tire. So let's just hit OK and let's hit save. So we like that. All right. Now, let's go to this box. All right. And let's just make the numbers for dry tire because we're talking about dry tire for right now. All right. So we have a dry tire curve in our throttle curve. We got 10 and 10. Well, guys, the speed controller is going to auto-linearize 10 degrees of boost timing at 10% throttle, 20, 30, 40, 50, 70, 80, 90, 100. So 1 at 10, 2 at 20, 3 at 30, 5 at 50, 7 at 70, 8 at 80, 9 at 90, 100 at 10 at 100% throttle. Okay, that is going to be applied by the rate your radio gets to full throttle. Okay, it's going to be applied by the rate your radio gets to full throttle. So if your radio gets to full throttle in 1 second, it will go from 0 to 100 in 1 second and apply 1 degree, 2, 3, 4, 10 in 1 second. Now, here we see full motor power 12% earlier in time. This does not indicate when we get to full boost timing. Full boost timing will still happen over here. The boost timing is dictated by the radio input to the speed controller. This is the motor power output. As far as the ESC is concerned, okay, it will be applying 8.8 degrees at this point with our 10 degree example, all right? It will not apply the full 10 degrees until it gets right here, all right? This is something people, I think, misunderstand. I've heard some people think that your full timing will come in right here. It will not. Your full timing will happen here, but we can ask for slightly more power to the motor and then use our timing appropriately. So this is the tuning strategy. You are going to try and find the best timing that you can across the throttle rate and then constantly be trying to get the most power out of the motor, all right? Because remember, by taking this and sliding it this way or this way, all right, we are asking for slightly more motor power for every change in the radio. So for every X change in the radio, our Y change is slightly greater, all right? Then you take it and you cross it over with your boost timing, all right? Now we have a powerful tool. Once we get into looking at the data, we're going to talk about how to determine some of these numbers, okay? But the thing to understand, from once we get right to this point, 100%, this is when our turbo will kick in. And our turbo will kick in once the radio gets to 100%, not our throttle graph. Once the radio gets to 100%, plus the turbo delay, it will apply turbo timing in this rate, the rate of the positive slope. So our positive slope is 1 second. It will apply 10 degrees over 1 second, or 1 degree every 1/10 of a second, okay? We will determine this when we look at our data. Now, let's go back to our throttle, and I'm going to leave this one here for dry tire, and I'm just going to move over, because you can have multiple in here. And let's start a new one for prep, okay? Oh, I'm sorry. You know, guys, I got a little bit ahead of myself. I'm going to cancel this. See how we're starting at 15% in this deadband? We want to make sure that our start power is at least equal to that. Now, there's nothing saying it has to be there. We can actually try more start power, all right? And this will, we'll analyze this when we look at data, all right? But a good place to start would be equal to your first dot. And I say for dry tire, this is a really good place. As a matter of fact, I'm actually recreating a curve that I literally just yesterday ran a 1.8 dry tire with 15% start power, this exact curve, and 10-10, okay? And playing with my radio. So already know that that these are really, really good baselines, because I literally just, and it's nothing special. It's just very simple, very basic. But again, so now we're going to create a prep curve. So same thing. I'm just going to go to, you can have up to 10 of them, but I'm just going to do this one. So again, I'm going to just delete. I like to start with a nice fresh line. Okay. And I'm going to put 1, 2, 4. I'm going to start off with these 4 dots, and I'm going to add the 5th one, but I like to do it this way. Now for prep, we need a lot more start power. All right. Now I'm going to tell you, it's pretty normal to use something close to 40 to start. All right. But I am going to say that when you're using about 40 to start, I'm probably going to think that, or I'm assuming that your car is just better. All right. Your car is just better. So let's just say we just built a car. We're unsure of how it is. Maybe we're by ourselves. There's not a lot of prep down. Maybe let's just think about something around 35. All right. So I'm going to kind of put this, again, same thing in the middle of the range. So 364 is 35. Then I'm going to take this dot, and instead of 10, I'm going to drag this out. So remember, the dry tire, I had this down at like 10. For prep, I'm going to drag this out to about 30. All right. I'm going to drag it out to 30. Now, the same thing, I want to put a deadband here. So I see that my y-axis is 364, 35%. I'm going to take my y-axis and make it 364. All right. Now, just like we did with dry tire, we are going to create a nice kind of smooth transition. All right. Now, for the sake of this video, I'm not going to spend too much time making this perfect, but we're gonna just kind of make a nice smooth transition. All right. Now I'm going to go here, and I'm going to add another dot. Okay. And you're actually going to make these a lot closer, something like that. All right. Now I'm going to add one more. And this last one is going to be exactly like this one. It's going to go up here. Now, again, guys, for the sake of making this video not terribly long, I'm not going to spend too much time making this into a nice little bend. But I would definitely suggest you guys spend time doing it and looking at these numbers and, giving some nice transition. Now, with prep, remember we talked about we need to overcome a lot more resistance. A lot more resistance because of the prep is eating so much power. So what we're going to do is now change our point from 6 to 10, which we were using dry tire, and we're going to, you see this first point is at 30. We're probably going to start at maybe 25, 26. Now, guys, this is very, very basic. This is basic. Probably going to start around 25, 26. And then we're going to work our way till we get to 30. And then, maybe this one's maybe going to be more like 32, something like that, 32, 33. Kind of like to keep them. I'm doing what I didn't want to do, spend too much time on this. But, and another thing is this arrow at the top will move you across your dots pretty nicely. Okay, so we're going to kind of smooth this out a little bit, and we can, you can move your dots and just play with this a little bit and make it nice and tight. But you want to get a nice kind of transition. All right. So the idea here is you'll start at a point that is in the deadband, and then you're going to move to your first dot. All right. Now, so this is the point on your radius. So right now, let's just say we have a minus 96, point of 30. That's going to put us right here. Then we're going to try to work our way to the next point. All right. So 32, 33, 34, 35. 35, we're here. All right. We can already tell at 35, we're at 37% motor power. We're here, we were at 35% motor power. Okay. So 35's good. We're launching good. We're making good progress. You see this next point here, and I probably wouldn't do full 41. I'd probably tighten that up a little bit. But anyway, we're going to look to see, once we start kind of going up this line and we're doing good, then it's time to move all of these dots. And what you're going to do is, once you have all your dots, okay, and you got a pretty nice curve here, just very evenly go through them and move them by the same amount, okay? And you're going to work your way up. I recommend everyone move their dots 5 points at a time, which is going to be 5%. Okay, so very evenly, you see this 412. Sorry, it's 50 points is 5%. My apologies, guys. 5% is 50 points. So if we want to move this 50 points, it's going to be 462. So we can just go to 462 and 462. We'll move to the next one. We're going to move it 50 points. So that's 467, but really we probably want 462 because the first one's a dead band. I was playing around with this a little bit. And we're going to move to our next one, and we'll move it 50 points. You see this is 443. So we're going to go 493. 493. We'll move to the next one. 482. So we're going to be 522. So we'll move it up. 522. And we'll move to the next one. 537. 587. All right. 587. All right. Again, guys, for the sake of the video, I didn't really smooth this out as much as I wanted to, but this is essentially what you're going to do. You're going to bump this up. You'll drop your point back down here. Then you're going to start working your way up this way and repeat the process. And again, once we're happy with this, then we can start trying to ask for full power to come in a little bit sooner. Don't be afraid to play with this one up here. Okay, but remember, our boost timing is going to start here and it's going to end here. All right, our turbo timing essentially is going to go from here over. All right, now, again, our prep is going to be something up in this range. All right, our dry tire is going to be something down in this range. The prep is going to be more aggressive because we need to overcome that resistance from the prep. That stickiness is slowing us down tremendously. All right. So we have a curve. We have our, for prep, our 30-20. And from this point on, we're looking at our data. Now, everything we're doing between the throttle curve and your boost timing curve is going to be circular. We're going to be looking at our data. We're going to go up, 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 up. We're going to keep going back around. We want to essentially form this nice circle of performance. All right, it's this performance envelope. We're going to want to look at that and determine how much we need. Now, remember, guys, from whomever you got your motor, you should already have an idea of what your maximum numbers in the speed controller are going to be. So how much is going to be applied maximum in the speed controller should be provided from the people that you get your motor. Okay, they need to be providing you with this information so you know what your maximum targets are. You always need to have some kind of target that you're going to be manipulating and working around. All right, so let's say let's say through testing and data and everything like that, we like this 30-20. We're happy with it. We like it, right? So what we're going to do, phase 2 from here, is now to go to our boost box, okay? And now what we're going to do is we're going to recreate this auto throttle, but with the boost box. So in this case, it's going to be 3, 6, 9, 12, 15, and finally 30. All right, so we already know now we are back to this, but now we've done it by gating it in these places. From this point on, from analyzing our data, we want to start to try and see, can we squeeze just a little bit more, a little bit sooner, all right? We want to do this. Now, especially with prep, we're going to want to try and apply as much power efficiently as possible. That does not mean as much power as you can hit it with. It is as much power as it's going to take, and also as efficient as possible, because we want to get the car moving through the prep. Now, we're going to start looking at some data, and we're going to determine how that should look and how we should be looking at our data. But this is essentially a big loop that we're going to make with our throttle, with our boost, our start power. So now our start power is up to, let's say, 45. And remember, guys, hit save. All right. So let's look at some data, and we'll talk about it. Now, the data that I have is data from yesterday. Is a dry tire data, but the same principles are going to apply for prep, and I'm going to show you some of the things you should be looking for. So for data, you're going to hit log, and if you don't have any data saved on your device and it's on the Speedo, you'll hit this download and you'll download it, all right? And then you're going to get a whole bunch of things that populate here. But because I've already saved it, I'm going to load it. And so I've loaded my data, and you're going to see it's all crunched together. The way you view it is by stretching the screen out. Now, I'm going to tell you, sometimes you'll get your data all the way over here, and you can't pinch you can't pinch it. All you can do is pinch the screen anywhere, and you'll spread the screen out, and then you just scroll. And what you're going to want to do is slide this to cover as much real estate as possible, and you have as much room to look at. Now, let's look at some of the lines we have here. Battery capacity, okay? This essentially is how much of the battery did we use during the run, all right? I don't really care to see the line, so I turned it off because anytime I put the cursor, it's going to be there. What I do like to see is my battery voltage, because I like to see the trend of my battery voltage. I like to see my current, my RPM, my throttle. I don't really care to see the lines for the ESC temp and mode. It just makes it messy, but I get that data when I click it. Now, something I'm going to point out before we get any further is that you're going to notice the RPM, and this was on a 4-pole motor. This is 186,000. This mode did not turn 186,000. The Yokomo speed controller, which I use because I like it better, does not have a option switch in the data to switch it from 2-pole to 4-pole. Now, you may think that's terrible, but it's not, because every speed controller, I don't care which one it is, works actually in 2-pole. The 4-pole switch is only there to change how you read the data, okay? And this is actually important to remember because there are a lot of speed controllers out there that you have to actually tune it as if it was a 2-pole, which means that if you ever, let's just say there's some speed controls out there that only have boost by RPM, you have to think of it in terms of double the speed that you want. So if you had a speed controller that only has boost by RPM and you're using a 4-pole and it does not have a specific 4-pole switch that is going to just flip the software, and that's all it is, flip the software, because it actually will always work as if it's a 2-pole. You have to tune it as a 2-pole. So essentially, let's just say you wanted your boost timing from 20,000 RPM to 50,000 RPM. If you had a speed control that only did boost by RPM, 20,000 to 50,000, you have to think of it as 40 to 100. You're going to have to double it for the 4-pole, because the 4-pole runs at twice the speed that it reports when you're doing this. So, essentially I'm reporting 186,000, but we are saying that our 4-pole is turning 50,000 RPM. It's just because it's a 2-pole versus a 4-pole. At the end of the day, guys, the number doesn't matter. If all you're doing is reading it at 186,000, it doesn't matter that that's 54,300 RPM. It's irrelevant. It's 186,000. When you read your data, did you see more? Did you see less? That's all that's important. All right, that's all that's important. Now, the first thing I like to do is take a sample in a couple different places, and I actually do a lot of screenshots, and I put it in a notes, the notepad in the iPad, and I make a log, and I do screenshots, and I keep records. But if you had a notepad, it would work. So one of the things I like to do is take an idea of RPM just below 50% throttle, all right? So you see here, I'm at 48%, and I'm at 32,400 RPM. My current is 114.5, all right? These are the three things I want to pay attention to: my current, my throttle position, and my RPM. So when I'm reviewing my data and I make another pass, I want to look and see, is my, at approximately this throttle percentage, did I make more or less RPM, and did I make more or less current? And we're going to get into when it changes, how do you know if it's good or bad in a second, all right? But essentially, we want to see just below 50 and then just above 50, all right? So like a maybe low 60 number, something like that. Now, it's pretty common to get this little line in your data. So I just try to stay away from it. So I'm at like 67%. So I did 48, 67. And again, I'm looking at my RPM, my current, and this. And I'm making a record of that. The next point that I want to see is what did I do exactly at the point I crossed from being under full throttle to exactly full throttle, which is going to be right here. Okay, and sometimes you're going to read 99, sometimes you're going to read 100, but it's right at this knee, right where it crosses. Okay, so here you see I'm at 81,100 RPM, 329 amps. Okay, 7.7 volts. You can tell I really wasn't pushing it. It's only 7.7 volts. I told you guys it was only 10 degrees of timing. Okay, so I do that, and then I like to look at somewhere near the end of run. All right, somewhere near the. I don't go right to the end, because the truth is that this is something past the the finish line. So I just kind of look somewhere about there, and same thing. I'm looking at my current. I'm looking at my RPM, and then as a good measure, I just take my very end number because usually I'm pretty consistent. I'm letting off the same place, but that's where I like to look. I like to look just before 50%, somewhere after, right at the 99, 100% mark, somewhere just before the end of the run, and at the end of the run. Okay, now let's examine the data and let's look to analyze it. Okay, so right here, we're going to start at the very beginning of the run. All right. Now, this is a dry tire run, so we're not actually expecting to see a lot of current because we just cannot put down the same power, but we also don't have the same resistance on the motor. Prep car is going to have a lot more resistance. If this was a prep car, what we'd be expecting is the current to go up very, very rapidly, pretty much straight up, okay? And then we're going to look for the current to kind of hold and have a very light taper off, and we'll talk about that in a second. And current is a good indication of load. When we have high current, we have high load. Now, that load generally means we have a lot of grip, but in the case of prep, it also means that we're experiencing a lot of resistance. And there's going to be ways of looking at that because sometimes we can have high current at the end of the run. Sometimes we can have low current at the end of the run. These are going to tell us a lot of things, especially with prep, okay? But here, you see that my current goes up and then it kind of flatlines and it goes up again. And my RPM is pretty, it's a pretty straight line, all right? It's not doing anything funny. What this is telling me is that I actually could, my dots I could have bumped them up, okay? I could have bumped them up. I could have probably even had more timing earlier because I had good grip, but then I just didn't give it enough power. So my RPM was a nice smooth increase. My current kind of flatlined, and then as my throttle starts picking up, the current starts to pick up. So really, from here to here, I should have had this current pumped up. This is telling me that I need to play with my dots. I need to be pumping my dots up, and somewhere just after my launch. Okay, so just while it's starting to curve up, I should have pumped those up. Now, if my RPM was rising up quickly right here, and my current was falling, that is telling me I have tire spin. My tire is spinning. That's telling me I'm overpowering it because when the current falls, it's telling you that the load is going away. But why is the load going away? In my case, the load's going away because I just didn't ask for enough power for how much grip I was making. But if I was at a loss of grip, I would see my RPM rising very quickly, okay? And the current actually would look a little bit different. It would be dropping off very quickly and then looking to come back up again. So it kind of makes like this V like that. When you see that, when you see RPM going up and your current dropping, that's a good indication that you are spinning the tire. When you see your RPM climbing and your current climbing, that means you have a lot of grip or you're overcoming a lot of resistance from prep. But nonetheless, that's really what you want to see. You want to see your RPM go up. You want to see your current go up. All right, that means that the motor is seeing a load. When the motor is seeing a load, it means that it has to overcome the load, and that means that you're either making a lot of grip or you're, in a place where you can be applying more power because there's a lot of prep. Now, you see, and now I start to pick up, and then even from here, you can see my RPM's climbing, my current is climbing. It peaks out a little bit, and then it kind of flatlines, and it picks up again. This is telling me that my positive slope was too slow. All right, remember I started with that 1 second positive slope. It was too slow. I was making good load. I got to full throttle. My RPM still climbing. I kind of flatlined on my current right here. Then I started building turbo, and then my current starts going back up again. You see my RPM is shooting back up. All right. At this point, I really needed the turbo to come in quicker, but I'm going to let you in on something. It could also be that I just did not have enough turbo, because guys, remember, on my dry tire, I was 10 and 10, all right? But because I was 10 over 1 second, it was 1 degree, 1 degree, 1 degree, 1 degree, like that. What if my turbo was 20 or 30? Then it would be 3, 3, 3, 3, 3, like that. I always like to go up on the value, leave the positive slope higher. The last thing I do is start shortening up the positive slope. Because guys, if I made it 30, then I'd be seeing 3, 3, 3, and maybe I'd be getting that pump up like this, okay? But if I leave it at 10, right? Now, all right, let's say you didn't realize that, you messed up. You left it 10 and you made your positive slope very small. You get your 10. What you're going to see is your current go up, your RPM go up, but then as soon as you run out of turbo, because it came in, your current just going to start falling off. And that's the indicator that you could have taken more load. You should have been hitting it with more load, okay? Which is why I like to go up on the number and leave the slope longer, so I'm feeding that across. When you have over-timed your motor, your RPM will really fall off. It'll start to flatline. You will have very little rise. Your change in Y over change in X will be very low, and your battery voltage is going to start to tank. When your battery voltage starts going down rapidly, okay, and your RPM is kneeling over, you have over-timed your motor, or your gear ratio is not right, all right? Or both, okay? Now, if this was a prep car, remember how we said we do like 30, 20? Because I want to see more load here. Ideally, for a prep car, I want to see this thing come, boom, off the line. I want to see my current shoot up and my current hold, and then very, very gently, I want to see see how this line is like depressed just a little bit, my battery voltage? I'd like to actually see my current after full throttle, hold, and then just very so gently come down, okay? And again, from your motor builder or whomever you get, they should be giving you targets, like how many amps should you be seeing here? How many amps should you be seeing here? How many amps should you be seeing at the end of run, okay? If you are really high amps at the end of the run, okay, that means that you're being dragged down. Especially on prep, means that you should have been hitting it with more power. Your throttle graph should have moved over. You're just dragging the thing if your amps are continuing to climb at the end of run, you have not hit it with enough power and you're dragging the motor down. Ideally, if you hit it with the right amount of power early on, you're going to see it come up, you're going to see it hold, and then you're going to have enough speed that your current it shouldn't be tanking, should just be leveling off, okay? Should just be leveling off. But again, my customers, I'll give them current targets at different places, and I'll give them, like you should be about this many amps here, this many amps here, this many amps here. And at the same time, I have targets for what kind of RPM am I expecting to see here, what kind of RPM am I expecting to see here, what kind of RPM, and what kind of RPM am I expecting to see at the end of the run. Again, that kind of information is going to help you with your gear ratio selection, because if you are especially if you're over speeding the motor, there for sure is a place where your motor power is just tanking. Because anyone who knows anything about motors, and I've written tech articles about this, motor power tends to be a curve that looks like this, okay? Torque, on the other hand, starts here. Torque only diminishes as RPM goes up, all right? Any brushless motor, torque is going to start its highest at the lowest RPM, and it only is going to go down. Motor power, on the other hand, has this arc, okay, where it's going to go up, 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 up. It's going to kind of, if you do a good job, it'll have this kind of wide little nose. Then it's going to fall off. And then the rate it falls off has a lot to do with the design of the motor and things like that, and your battery voltage and how your time. But there is definitely a speed where it's going to fall off gently, and then it's going to fall off quickly. When you overspeed the motor, you're going to get to that point in the power just falls off quickly. You need to know that, and then you adjust your gear ratio so that you're hitting your target RPM. You couple that with your throttle graph and how you're hitting it with boost and turbo. That's going to be the winner. Now, guys, I'm going to tell you, battery voltage is everything. Motors are kV, RPM per volt. Timing influences kV. So the more timing you have, okay, the more kV you have, which is more RPM per volt. The problem is two. If you overtime the motor, okay, you will see a drop in kV at load. So let's just say that motor free spinning was 10,000 kV with a certain amount of timing, all right, free spinning. But now if it's overtimed, when you put a load on it, it may drop kV. Maybe it drops 500, maybe it drops 1,000, maybe it drops 2,000, okay? Because it cannot achieve that target kV. The second thing that happens is that when it's dropping like that, your battery voltage drops. So remember, the motor is kV, RPM times volts, okay? If you had a motor that was 5,000 kV, 5,000, and it was 10 volts, right? I know we don't run 10 volts, but I'm just doing easy math. 5,000 kV and 10 volts, that motor would be seeing 50,000 RPM. Now, okay, let's say we have a motor that is, let's just say 8,000 kV. But we go down to 5 volts, and I know you guys have seen 5 volts. You go down to 5. Now, your 8,000 kV motor, even though it's 8,000 kV from whatever, it's only seeing 35,000 RPM, guys. All right? The 50,000 RPM is going to win. And that's why when I tell people, pay attention to your RPM. Pay attention to the RPM that you're seeing. And it doesn't matter if you're reading it in 2-pole or 4-pole. At the end of the day, this is reporting the actual RPM from the motor. And that's what's really important. You look at your battery voltage, you look at the current, you look at your RPM, you make a log of it, and what you ultimately want to, I don't care if you're dry tire or prep, you want to see the most current that you can with your RPM going up at some rate that looks reasonable and predicted. If it's shooting straight up, guys, you're spinning the tire, all right? It's just not going to do that. If it's shooting straight up and then it's kneeling over, that means you spun the tire like crazy. your vehicle speed is not appropriate, and then it just bogging the motor, and you're just going to kneel over. All right, your RPM should be going up at some nice angle. Okay, if it's just whizzing up and then your current, that's just tire spin. Okay, so again, we're going to think about where we are with boost timing. Boost timing is going to pump up this area. Turbo timing is going to pump up this area. Our throttle graph, all right, is going to help influence how much torque we see here and how much current we see here. The whole idea, guys, is we want this RPM to come up as fast as possible without spinning the tire. And we know that because we're making good current, means we have good grip, means we have good drive. And it's exactly the same for prep as it is for dry tire. We're just never going to realize the same amount of current dry tire. Okay, we're just never going to see it. But prep, if we're doing our job right, we want to boom, come off the line. This thing needs to be shooting straight up, holding, and then a very, very light taper after full throttle down. And we want to see our RPM increase really nicely without it being wild. And we really want to see it just go straight up. Again, like I said, guys, you can clearly see my turbo timing was not appropriate here. I did not have enough turbo, but you can see once it started stacking in, it started going. So I started to slow down and I picked up again. And you see that my current kind of didn't drop. It just kind of held flat and then it picked up again. So was 10 degrees too much? Probably not, because I was still only 7.7 volts. Probably needed more, and I definitely needed to come in sooner. But like I said, guys, I'm going to just recap here. We're going to use these curves here, something like this for dry tire. And we're going to adjust the start power. Remember, guys, when you do this, do this, okay? This and this go together. Yes, you can go a little bit higher. I wouldn't go any lower. This is for sure is a tuning tool. Remember, this is the amount of power just as it cracks over here, and then boom, it's going to drop down to here. And then your boost and turbo, this is where you're more advanced. You start shortening up your turbo positive slope. It means your turbo comes in quicker. And remember that this is where you make the adjustment. And then this page here is for that. So I know this was lengthy. I think we covered a lot of ground. We definitely covered the basics, some advanced tuning. And everything I gave you guys is just a base. I think these are really good base ideas. You can use what I gave you. But a really good base. This is not where you're finally going to be. But there are some things that you really should be getting from whomever I don't care if it's the manufacturer of the motor or a motor tuner or something. You should be getting a good idea of where to start with your FDR. You should be getting a good idea of what your target RPM should be end of run, what it should be around 100% throttle, what it should be about mid-throttle. And you should have a good idea of about how much current you should be pulling. And when you get that information, then you have a target to tune for. It's kind of funny, but you think about why so many people have had a hard time with this. This is because you're shooting for a target that you don't even see, right? It's easy when you put up a paper target and there's a bullseye and we miss and we can see how far we are from that. But when we don't even know where the bullseye is, guys, how are we going to hit it? And this is why we're doing these videos, and this is why Exotek is sponsoring these videos, because they are dedicated, as I am dedicated, in helping you guys understand what you should be doing and what you should be shooting for. Remember, guys, if you don't have that bullseye, how are you going to hit it? It's just a shot in the dark. So I hope you enjoyed this video. I'm going to be making another one for a hobby wing and another one for DRK. And that's it. Please feel free to ask me any questions. Send your comments in, and happy RCing.